Hello class, welcome back. This tutorial will introduce association rule mining and how can we implement association rule mining in R. And association rule mining is basically finding the interesting correlations between variables, and we will go through this tutorial. This tutorial is a sample tutorial code from Machine Learning with R book, chapter 8. And the data used for association rule mining is a little different from what we used before. Let's first look at the data set. So here you can see each row in this data set has different column size. So for example, for the row 1, it includes 4 items. For the row 2, it only includes 3 items, and for the row 3, it only includes 1 item. And each row represents one transaction for this grocery store. So for example, like one customer purchased this tropical fruit, yogurt, and coffee that time, and then another customer only purchased whole milk for one transaction. So let's first import this grocery dataset into R. So first thing is you need to install the package arus. After install this arus, you need to load this package. And instead of using read.csv function to import our dataset, here we use read.transactions function, and to separate them with a comment. I'm sorry, this one. So let's look at the summary of this dataset. So you can see it summarized to you. In total, we have 9,835 rows, which means transactions, and 169 columns, which means in total we have 169 distinct products items. And the most frequent items are the whole milk, which appears 2,513 times in this total transactions. And yogurt, the total frequency for yogurt is 1,372. And the next is the element length distribution. What does that mean? So for the transaction, which only include one item, so people who only purchased one item in this grocery dataset is 2,159. So for the transaction that include 32 items, which means that person purchased 32 items once, but it only happens once, so the frequency is 1. And this is the summary, like statistics for this length distribution. And next we are gonna to look at the first 5 transactions. We use this inspect function to when you want to check the values or atoms inside this grocery. Groceries now is when you do this read transaction to import this dataset into this grocery. This grocery variable now is matrix. We'll talk about this matrix later, but now let's first look at the first five transactions. So it basically transformed our original dataset into the first row into the item 1, second row item 2, so on and so forth. And well, so this groceries now is a matrix. Each row each row represents each transaction. Well, in total, it will have 9,800 and something. Like how many transactions are there? There will be how many rows? Well, in terms of columns, because we have 169 distinct products, distinct items, so we will have 169 columns. And we want this, and the columns are ordered, are in alphabetical order. So when we want to see the columns from 1 to 3, those 3 columns are in alphabetical order. And noted here we use another function called item frequency. Well, item frequency will present you with the percentage of frequency those items purchased in the total transaction. So here let's see the first 3 columns of this matrix. And oh, okay, you can see here the first 3 items that ordered alphabetical order in alphabetical order is this abrasive cleaner, this artificial sweetener, and baby cosmetics. So when we use this item frequency, we can get the percentage of frequency of these items appears in all the transactions. So here, like about 0.3% of the transactions include this cleaner and this sweetener, but only 0.06% of the transactions include this baby cosmetics. Well, next we will apply this item frequency plot function to display some of the items, some of the products when they satisfy certain conditions. For example, the condition 1 is support equals to 0.1. So we want to display those items, those products, the frequency that these items appears is more than 10% of the total transaction number. So let's plot these items first. So you can see in total we have 8 items that satisfy this condition, and the product with highest frequency is of course our whole milk. And next condition is we want to plot the frequency, plot of the item that is in the top 20. So it will output 20 items that in descending order. Well, next we will use this image function to visualize this matrix, this grocery matrix I just explained before. So we want to visualize this matrix for only 5 transactions, so for the first 5 columns. And well, it may be a little small for you to see, but you can see here in total we only want to see 5 rows, top 5 rows. So we have from row 1 to row 5, and we have how many items? 169 distinct products items. So in total we have 169 items. And for the transaction 1, you can see it has 1, 2, 3, 4 different items. And for transaction 5, we can also see 1, 2, 3, four different items purchased in transaction 5. And you can also see from here, like transaction, there's one item that purchased both in transaction 3 and 5, and there's another item both purchased in transaction 2 and 4. Well, this matrix, this visualization of matrix is very important for you to like get a general idea of the distribution of the items. So next we will like randomly select 100 rows, 100 transactions, and to build another like matrix image. Well, here we will use this sample function embedded in this image function. So the first parameter is still this groceries matrix, and we only select 100 rows, 100 transactions, randomly select. So that's why we use this sample function. So let's see this matrix, see this graph. So you can see now we have a pretty larger image with 100 rows, but still 169 columns, and the high density here, and here means these items has been frequently purchased. Well, for those empty low density area, I can see, well, those items are not purchased frequently. Well, the next step is train a model on this dataset. This model is an association rule model, and we use this function called a priori. Well, this a priori, inside the parentheses, we only include the matrix, the grocery matrix only, and using the default setting. However, when we use the default setting, you can see it results in 0 rules, so we don't have any rules generated. While the default parameter values is support equals to 0.1 and confidence equals to 0.8, and the main length, this main length, minimum length of item equals to 1. However, like no rules satisfy that condition. So here we adjust the parameter values. So here support equals to 0.006 and confidence is 0.25, and we want the rule at least to include 2 items. And let's see how many rules it generated. In total, it generated 463 rules. And let's see the summary of the rules. All rules are stored in this grocery rules parameter. This variable. So you can see this is a summary of all the rules. These 463 rules. So rules include only 2 items is 150, and there are like 16 rules include 4 items, and we have like 3 different measures to evaluate those rules. They're like support, confidence, and lift. And next we want to look at the first 3 rules. So we use the index from 1 to 3 to include and display only the top 3 rules. So the first one is potted plants. So when you purchase a potted plant, you probably will purchase the whole milk, and so on and so forth. They also present you this support, confidence, lift parameter measurements here. Next, we want to output the rules with highest with highest lift value, like top 5 highest lift value. And we will use this sort function to first sort the grocery rules by lift values, and then only output from index 1 to 5, so only 5 rules with highest lift values. And remember, when you look into the rules or other parameter, other measures, you need to use this inspect function here. So let's see the rules with highest lift values. So here we can see yeah, this is the one we saw before. And also the second one is, if you purchase berries, you will probably also purchase whipped or sour cream. And well, next one is to find the subsets of rules containing certain items. For example, we want to find all the rules that contain the item berries. So we'll use this subset function. And for the second parameter, we use items. And this simple and berries, the exact item names here. This is percentage sign and in and also percentage sign. So it will output, it will extract all the rules with berries and return those rules to this berry rules. So let's see. And let's look into those berry rules. So there are in total 4 rules that contain the item berries. Well, this one we already saw, and the rest of them are also the rules that contains berries item berries. And well, we've got those rules, and we want to output these rules to a CSV file. Well, this one, when you write the CSV file, this file will be read to your working directory. So here my working directory is my desktop. So you can see my rule is here. So let's open my rules. Well, the rules, the first column is the rules. So all the rules are included here. And the second, third, and fourth columns are these measures: support, confidence, and lift. And also we can convert the rules into a data frame by using as and the second parameter set as data.frame. So let's see. This data frame now will include 4 variables. The first one is a factor variable, include all the rules, and the from third to fifth, there are like support, confident, and lift measures. So that is how you generate association rules in R, and that is all we have for this tutorial. Thank you for listening. Bye.